All right, now we'll take a look at the 10.5 theorems. The first theorem involves when you have a chord and a tangent that intersect at a point of tangency. Again, a chord is a segment that's inside the circle, and a tangent is a segment outside that touches the circle at exactly one point. The angles formed between the chord and the tangent are exactly half the measure of the intercepted arc. So angle 1 here is half the measure of this arc, and angle 2 here is half the measure of the major arc. Next theorem actually has a cool name, the angles inside a circle theorem. Here, when you have two chords that intersect inside the circle, the angle formed, and really both the angles formed, because we have vertical angles are congruent, of course. The two vertical angles formed are going to be the arithmetic mean, or the average, of the two arcs, the two intercepted arcs. So angle 1 and its vertical partner over there are the average of these two arcs. And then angle 2 and its vertical partner, they're the average of these two intercepted arcs. So just add the two arcs together, divide by 2, and that's how you get the interior angles. The next theorem, the last theorem, is also one with a cool name, angles outside the circle. And this is when you have either tangents or secants, or a combination of the two, intersecting to form an angle outside the circle. Now this one, here we're actually going to take half of the difference of the large intersected arc minus the smaller intersected arc, and that's going to be the measure of the angle formed. So the measure of angle 1 here, we're going to take the larger intersected arc, subtract the smaller intersected arc, and take half of it. And this is with one tangent and one secant. Here in situation number 2, we have two tangents. The measure of angle 2 here is the larger arc measure minus the smaller arc measure, and then divide by 2. And in the third scenario here, we have two secants. So the measure of this angle 3 here is, we're going to take the larger arc measure CD, subtract the smaller arc measure AB, and divide by 2. All right, so tangents and or secants intersecting outside the circle, we're going to take the larger intersected arc, subtract the smaller intercepted arc, divide by 2, and that is the measure of the angle formed by the two line segments. All right, a couple examples ready to go. Here we have an angle inside the circle. So x, for example, is going to be the average, add the two together, divide by 2, of the intercepted arcs. Now everything's in degrees, so technically degrees cancel out, and when you're solving for a variable, you don't actually need a unit label. So let's solve this down. So 85 plus 145, that's 230. And then half of that is 115. So that's 115 degrees. And then we can get y easy enough because x and y form a linear pair and they have to be supplements, so y is going to be 65. Y degrees is 65 degrees. So y is just 65. All right, so again, x and its vertical angle partner are both the average of the two intersected arcs. And then the other linear pair angle has to be the supplement of the original angle you just found. All right, here in number 2, we have the measure of angle BAD. This angle right here is 72 degrees. And the theorem states that the angle is exactly half the measure of the intercepted arc. So we'll just multiply that angle to get by 2 to get the intercepted arc is 144 degrees. Now there's 2 ways that you can go about solving this problem here for the other half. And both get you the same answer. So we can either take the supplement of 72 degrees, call that 108 degrees, and then the arc is going to be twice that. Excuse my bad handwriting. Or the other way we can do it to also give us the same 216 is the major arc and the minor arc together must add to be 360. So you can just take 360 minus 144 and get 216 that way. So a couple of ways you can think about it and you get the same answer because math is awesome. All right, the last 3 examples here, remember it's ultimately a subtraction problem. The exterior, well, it's not really exterior angle, but the angle formed outside the triangle, that's totally a circle. The angle formed outside the circle is half the difference of the 2 intercepted arcs. So we're going to take the larger one minus the smaller one and divide by 2. So the angle outside the circle is 1/2 the further away intersected arc minus the closer intersected arc. Degrees factors out of this whole problem. I didn't really need to put degrees in there because it just divides out of every term. So here, let's not bother distributing with this 1/2 because that'll complicate the x, but rather multiply both sides by 2. That'll get rid of the 1/2. So 29 times 2 is 58. Oops. Make it look like I meant to do that in degrees. Again, degrees just factors out. And then we'll subtract 144 from both sides, 114 from both sides. I really wanted to say 144 there. And I get negative x equals, let's see here. Oh, we got to borrow there, don't we? Yeah. So 6, and I think it's 56. Negative 56, multiply both sides by -1, so positive x is positive 56. But the setup, again, the angle formed outside the circle is 1/2 the difference, the further arc minus the closer arc, the intercepted arcs, that is. Here, with 2 tangents, we don't know directly the smaller arc, but we can figure it out because the two arcs together must add to be 360. So if this is 242 degrees of the major arc, then the minor arc has to be 360 minus 242. And then we can set up our equation that the angle outside the circle is equal to half the difference. All right, and I embarrassed myself by getting math wrong on mental math while I'm shooting this video, so let's use my little calculator off to the side there. And then half of that is just 62. And again, technically x degrees, but degrees factors out of both sides of the equation. And then lastly, save the funnest one for last. It's pretty much the same theorem that we just did in the last two examples. The exterior, I keep saying exterior angle because it's outside the circle. It's not technically an exterior angle, it's just an angle outside the circle. The angle outside the circle is equal to half the difference of the interior. Now, this one's a little tricky. I definitely tried to throw you off a little bit. We're not just subtracting this x, we're actually subtracting this entire expression. So we do have to distribute the negative here. Let's get rid of this 1/2 simultaneously. We'll just multiply both sides of the equation by 2. That doesn't actually make my life easier. I won't do that, actually. I'm changing my mind on that on the fly. So 3x minus x is 2x, and then -2 minus 6 is -8, and now we'll just do that half. So 34 equals x minus 4 when we distribute the half. And lastly, just add 4 to both sides. X equals 38. All right. Circle all my lovely answers. Love it. All right, good stuff.